Now let's begin with section 5.6. So in the section 6, we talk about the right triangle trigonometry. I just say a right triangle is a triangle with a 90-degree angle, right? So you have the triangle like this. And then in this triangle, we have one angle with 90 degrees. Okay. So when we define the sine and cosine and all the other trigonometric functions, we need the coordinate of the point of intersection of the terminal side with the unit circle. So right now, if we don't know the coordinates of the point of intersection, instead we know one point on the terminal side which is not the point of intersection, can we use the coordinates of that point to find the sine cosine of that angle? Now let's look at the one graph. Okay, in this graph, and we have an angle which is in the quadrant 2. Actually, it doesn't matter which quadrant it is. And we can use the same argument to find the sine and cosine later. So now, this angle is in the quadrant 2, and we know the one point on the terminal side of this angle which is not the point of intersection with the unit circle. Then we want to use this coordinates x, y to find the sine cosine of alpha. Let me call this point O, and this one, let me call it P1, and let me call this point Q1, and this point Q, and this point P. So now you compare triangle P1 O Q1 and triangle POQ. They are similar, right? These are two similar triangles. So this triangle similar to triangle POQ. And we can find the length. Okay, we can find the distance between the O and P. So OP, this length of this segment, is equal to the square root of x squared plus y squared by the distance formula, right? Here this is origin, and this is the xy. So the distance between the P and the O is equal to the square root of x squared plus y squared. And how about the OP1? OP1, this is just the radius of the circle, right? So its length is equal to 1. And also OQ1. OQ1, this is same as the absolute value of the coordinate of this point of intersection, right? Which is equal to the absolute value of x1. And then OQ, this is the absolute value of the x coordinate of this point P, right? The absolute value of x. Okay. Now, we know for the similar triangles, the ratios of the length of the corresponding sides are equal, right? Then we can set up such equality. So let's go to the whiteboard. We have the P1 Q1 to PQ equal to Y1 over Y. You look at here. P1 Q1, this is the y coordinate of this point P1, right? And PQ, this is the y coordinate of the point P. So we have the P1 Q1, which is equal to Y1, and PQ, which is equal to Y, because in the quadrant 2, both the Y1 and Y are positive. And this guy is equal to OP1 over the OP. And you see here, OP1, okay, this side, and the OP, this side. So you have the P1 Q1 over the PQ, same as the OP1 over the OP. So this is the same ratios of the corresponding sides of these two similar triangles. And the OP1, this is just the radius of the unit circle, so it's equal to 1. And OP, that is distance between the P and O, we just found it. So that is the square root of the x squared plus y squared. And we use R for this distance, square root of the x squared plus y squared. So this can be written as the 1 over R. And this is the first trigonometric ratios we set up. Then let's look at the second trigonometric ratios. Now in these two triangles, we have the OQ1 over the OQ, same as the OP1 over the OP, right? So this is the ratio of the corresponding sides of these two similar triangles. Now let's write this down on the whiteboard. So you have the OQ1 over the OQ equal to the OP1 over the OP. And OP1 is just equal to 1, OP is just equal to R. And what is OQ1 and the OQ? Let's go to the graph. OQ1, that is absolute value of x1. OQ, that is absolute value of the x, right? So this is equal to the absolute value of x1 over the absolute value of x. Then from here we have, okay, when we rewrite these two equations, we have the y1 over y equal to 1 over r, and from this we just multiply both sides by y, you get the y1 equal to y over r. And then we have another equation, the absolute value of x1 over the absolute value of x equal to 1 over r. Since the x1 and x have the same sign, negative, right? So if we remove this absolute value plus, then we can have the x1 over x equal to 1 over r. So actually, since the x1 in the quadrant 2 is negative, so this should be equal to negative x1. They should be equal to negative x. You cancel this to negative sign, then you get the x1 of x equal to 1 over r. So this just implies x1 over x equal to 1 over r. Then we multiply both sides by x. We get x1 equal to x over r.